Hello guys, welcome back to my YouTube channel. My name is YAHMAD. So in this video, we're going to continue our computer science tutorials and we're going to be looking at hexadecimal. So hexadecimal is base 16. It's made up of 16 characters, including numeric values and also letters. Just to compare, in a previous video, we looked at binary, which is base 2. Binary is only made up of zeros and ones. So hexadecimal increases by the power of 16, and we'll come back to this table in a moment. So let's look at this table instead. So what we have initially is our denary values. So these are the values which we're used to every day. We use in pretty much anything we do when we're counting or adding. So we have in total 16 denary values here. And then the hexadecimal, the first part is exactly the same. So we start from 0 to 9, which are numeric values. So it's exactly the same. So 5 denary is also 5 hexadecimal. But when you get to 10 to 15, these values are now represented by letters. So 10 is equal to A, 11 is going to be B, 12 is C, D is 13, E is going to be 14, and F is 15. Now, the next thing that we'll do is we'll write the binary down for each hexadecimal. So for each hexadecimal, we always have 4 binary bits. So if it's 0, it's going to be, let me just change the size of this. Make it a bit bigger. There we go. So 0 is going to be 0, 0, 0, 0. 1 is going to be 0, 0, 0, 1. For 2, it's going to be 0, 0, and then we put a 1 underneath the 2. For 3, 0, 0, 2 plus 1, which is 3. And then for 4, we can put a 1 here and then 0, 0. So hopefully you guys get the idea now. So this is a binary, this is a hexadecimal, and then this is a denary here. So we're on 5 now. Put 0 there, 1. And for 6, it's going to be 4 plus 2. So you can see we have a different combination every time. For 7, it's going to be 4 plus 2 plus 1. For 8, it's going to be 1, 0, 0, 0. For 9, it's going to be 8 plus 1, and then 2 zeros in the middle. Whoops. And we can continue with the letters as well. So how would we write A into binary? Oh, yep. So what we need to do is basically equal up to 10. So 8 plus 2, 0, 0. 11 would be 8 plus 2 plus 1, which makes 11. 12 would be 8 plus 4, and then 2 zeros. Whoops. And then 13 would be 8 plus 2. No, sorry, 8 plus 4 plus 1. And almost done. So for E would be 14. So A plus 4, which is 12, plus 2, which is 14, and then 0 here. And then for 15, we basically got all ones. Okay, so 8 plus 4 plus 2 plus 1 is equals to 15. Right, so what we need to do in this second task is to convert hexadecimal into binary. So remember, each hexadecimal value is equal to 7. So each hexadecimal value is equal to 4 bits of binary. Okay, so you can see I've kind of shaded the areas. So this one would be for this value, and then this one would be for this one, and so on. So when you are doing these types of questions, it's always useful to have this little table here just to remind you of the denary values and the hexadecimal values. The binary needs to add up to the denary values. So let's have a look at the first example here. So we've got E. So E is 14. Okay, so to add up to 14 is going to be 8 plus 4, which is 12 plus 2. Okay, and then 0. I'm not sure why this is highlighting, so let's just take that off that pen. And then 7 is fairly straightforward. We just want to add up to 7, so it would be 0, 1, 1, and 1. So 4 plus 2 plus 1 is equal to 7. So this was an 8-bit register. We've got 8 bits here in total. Let's look at 12 bits. And B is going to be 11. So 8 plus 2 plus 1, which is 11. C should be 12. Yeah. So 8 plus 4 makes 12. Take off that highlighter pen again. Okay, and an E is going to be 14. So it's basically, if I come back to here, 1 plus 1 plus 1 and 0, which equals 14. Right, so that's the first part of the hexadecimal video series. What we're going to do is I'm going to make another video to follow up. So in the second video, we're going to be looking at converting hexadecimal to denary, and it's going to be a couple of methods which we're going to share, and also converting denary to hexadecimal. Okay, so thanks for your time, guys. Please drop your comments below and join us in the next video. Thanks again. Bye-bye.